You're listening to Gradient Dissent, a show about making machine learning work in the real world, and I'm your host, Lukas Biewald. Percy Liang is an associate professor at Stanford University and a co-founder of TogetherAI, a platform for building generative AI. He also created HELM, a well-known benchmark for evaluating large language models, and Codalab, a research platform that makes foundation models reproducible. He's also an avid musician, and actually the music here was created with an anticipatory music transformer, a technology developed by his lab. I hope you enjoy this interview. The place where I wanted to start was something that I've cared about for a long time, and so have you, which is benchmarking machine learning algorithms in general. I think you're well known for the HELM paper and the HELM evaluation framework. For people who don't know, could you describe what that is and kind of tell us the story about how you came to create that?
Yeah. Thanks, Lucas. So we created HELM, which stands for Holistic Evaluation of Language Models, back in 2022, which is eons ago. The feeling was that language models were a different object, unlike classical machine learning methods, because they were so broad, and the idea of how do you benchmark something that just has a text in and text out? You're not benchmarking just question answering or summarization or text classification. So we decided to embark on a journey to figure out how do we evaluate language models holistically, looking at both the capabilities and also the risks. And the project actually came about through a very interesting initiative within the Stanford's Center for Research on Foundation Models. This was been inspired by the big science project from led by Hugging Face and other more decentralized approaches, where within the center we said, hey, we're doing a new benchmarking. Anyone who wants to join and participate and chip in, feel free to join. So we had people sign up to do various who are interested. Some people interested in reasoning, some people interested in bias. And then we sort of organized people into these areas, which eventually included things like bias and reasoning and robustness and calibration and various capabilities. And then we built the infrastructure to hold everything together. So the end result was basically a pretty exhaustive to the extent that we could, get our hands on all the data sets evaluation. At least at the time, it was the most comprehensive evaluation, where we took 30 different models that we had a hold of through either API or open weights. And we looked at 7 different metrics, from accuracy, beyond accuracy, including bias, calibration, robustness, toxicity, and so on. And then we looked at 40 plus different scenarios, which are different data sets. And then we basically filled out this whole matrix. We were careful to standardize the evaluations using the same prompts and same methodology across all the models and data sets, so that it was you had apples to apples comparison, and then we put it out. I think one of the things that I'm especially proud of is that not only did we have the results on our website, but you can drill down into the results and see what the actual predictions of the models are. And furthermore, if you drill down into the predictions, you can see the actual prompt that was passed to the actual API, which we cache. So this is something I've been interested in a lot, is not just benchmarking, but also reproducibility, so that you could have a full audit trail of what you did to get your benchmarking results. So that was back in 2022. Obviously, this field moves incredibly quickly, and over time, we've added more benchmarks. We added all different models. And I think HELM is now evolving more to become a platform or a framework where people can build other types of benchmarks of themselves. For example, we're collaborating with ML Commons on creating this AI safety benchmark as part of the AI safety working group. We also have HELM used to support other projects such as HELM, which is text-to-image generation, and we're doing multimodal generation, instruction following, and I'm happy, I guess, to maintain HELM as a platform that can foster research and also keep track of what is going on in this fast moving space.
And now, I mean, your benchmark, I think, has become, fairly important to model builders. Do you worry that there could be an effect of people building to the benchmark, especially because you're so transparent about how the models do on the specific examples?
Yeah. Oh, yeah. I think gamification of leaderboards and benchmarks is a thing that happens. Whether I think you kind of like it or not, or whether people are intentional or not about it. I think,
or even the models might crawl the benchmarks, right? I mean, even inadvertently, you could imagine they get copied somewhere and somehow it gets into the model.
So I'm less worried about sort of overt copying, because I think those cases are easy to detect. And I know that some model providers also filter benchmarks. Not everyone, but some people do. So there's a sort of more of a clear solution around that. We've also been doing some work where we're working with model developers to run a standard train test overlap script to see how much overlap there is. And there is, I would say that there's no like smoking gun. It's like this model got really good accuracy just because it was trained on literally the test set. I don't think that's really true. I think the bigger and harder issue to worry about is the interpretation of what these benchmarks are really measuring. Because I think if you look at the, let's say the GPT-3 paper, we trained on the web, and oh, by the way, we're just going to evaluate all these standard benchmarks, and look, it's zero shot or few shot performance. Like, wow, that's very impressive. But I think if you start thinking like, well, the MMLU is we have a lot of good numbers on that. Well, we're not going to put the MLU data set in because that would be too blatant, but we're going to find the topics that are covered or maybe create some multiple choice questions using synthetic data. I feel like it's a pretty slippery slope before you're really overfitting to the benchmark without maybe even realizing it, because who doesn't want better benchmark numbers? And I think this is one problem, which I hope we'll talk more about, is the lack of transparency around these data sets makes it really hard to interpret what's going on, because so-called zero-shot performance, is that really zero-shot when, let's say, hey, it does zero-shot summarization? Well, I don't know. Maybe there were already summarization data sets, not the ones that we're testing on, but other summarization data sets which gave it summarization capabilities. And if that's the case, that's fine. Of course we want to target a task that we all care about, but calling it zero shot is maybe a little bit not accurate. And so I think of this train test overlap issue as not like, I'm not trying to police people and say like what you can and cannot put in your data set. Like, of course you add Wikipedia, even though we have data sets that involve Wikipedia, but it's important to just contextualize the results that you're seeing and the amount of surprise that you should feel when your model is working really well. If it's really close to what you've seen, then that's fine, but you shouldn't be surprised. Whereas if it's very far and is working very well, then you should be more surprised and impressed.
Well, I'm kind of reminded of an interview I did years ago with the founder of Kaggle, Anthony Goldblum, on this podcast. And one of the things that stood out to me is he mentioned that, Kaggle obviously does some kind of benchmarking. It's kind of like competitions where, you win a prize if you get the highest accuracy on a particular task. And so people are highly incentivized not to overfit, right? They'll kind of give you a score on, some held out data, and you can kind of keep getting a score on that. But then ultimately, to avoid overfitting, the final score is on even yet another hidden set of data. And so people are highly incentivized not to overfit because they want to win on the, held out data. And he says, even even though these people have no incentive to overfit, they still overfit because they still typically get significantly higher scores on the held out data they can't see versus the held out that but they can't see, but they can like test their model on and get a score, versus the data that they only have like one shot to get a score on. So that kind of convinced me that even the most well-meaning ML researcher with the best set of incentives would still overfit to a significant degree if they can just even test their model in some data set for some period of time.
Yeah, and with language models, I think it's worse because you're overfitting at the task level potentially, rather than just the distribution or instance level.
But then on your data set, like how should I interpret the results? I mean, it seems possible that some of these models are overfit on the data. I mean, the question honestly, the most common question that I get these days is, Lukas, how do I decide what model to use? And so, I tell them to look at the leaderboards, kind of pick a couple of the top ones and see how it goes. But certainly that, if someone just did that technique, they might be getting significantly overfit models. How would you actually answer that question of, hey, what model should I further investigate using? There's certainly too many to try them all.
Yeah, I think that of the top models, it maybe doesn't matter as much. And in terms of this general leaderboard performance, and what will matter more are other issues like reliability and cost and the ability to fine tune on your particular data set. Because I think most of the time, if you're interested in a particular application and you're like really investing in it, you want to fine tune and get a model, especially if you're generating data that you want to kind of feed back into the model itself. So at that point, the leaderboard is just like guide. And I think you could make an argument that really things that matter are just having a strong base model, and all the various like instruction tuning that people do on top of that is not really super essential for if you plan to fine tune anyway. I mean, it depends on the task. And so I think of HELM as almost like a base model evaluation. That's if you think about it, back in 2022, right? This is basically what we had. We had GPT-3, and maybe there was some, I think the Instruct GPT paper came out that year. I think maybe during the middle when we started the project. So it was really a base model evaluation scheme, and this idea of having few-shot learning. And I think for that, if you really are just training on some bunch of web data and in evaluating in a zero-shot way, I think HELM is should be fairly reliable. But if you start doing all sorts of instruction tuning and various things on top of that, then it sort of loses its I wouldn't call it overfitting in the conventional sense, but it definitely starts giving you over-optimistic views on how well a particular model is working. And I think one thing that I certainly wouldn't just take the top model off any leaderboard and just run with it without asking questions, because at some point you also want the simplicity, you want the trust of like, okay, who made this model, what is it in the data set, and so on. And unfortunately, many of the models are, especially on the OpenLM leaderboard, it's just, I don't know what's going on there. It's just a bunch of weights that happen to do well on this benchmark.
Well, I mean, let me ask you this. I mean, if I came to you and I said, hey, Percy, I'm thinking about deploying some LLMs inside my company. I'm probably going to do some fine tuning. What model should I start with? How would you answer that?
Well, the first thing I would say is that don't get too attached to any one model, because like in the month,
totally
there's going to be a new model that comes out.
But I got to start with something, right?
So you start with something. I mean, I think, Llama, Mistral, or Mixtral are probably reasonable starting points. And, just because they're, especially with, if you're going to fine tune, then I think that it's a pretty solid model at the 7B or I guess sometimes 8 for MOE scale. We've had some success. We put out a paper on using Mistral and Llama for VLMs, and we actually just used a base model instead of instruct model, and then fine tune because we're interested in different kind of VLM applications, and it worked pretty well compared to even some of the fancier instruction to models. So I would recommend starting fairly simple if you're going to fine tune. If you want to do zero shot, then you probably want a good instruct model, but there's reasonable instruct models out there. I think that is a fine starting point. Of course, it depends on what you want to do. Like if you want code generation, then there's other models like StarCoder that are out there that you can use. But one thing that I think is maybe a general recommendation is that design your application to basically be make all these models really swappable. You have your own evaluation that you trust downstream, which is tailored to your task, and then you can swap in a different model and then see how well it does. Because you're going to have to do that anyway, and in 3 months there's going to be a new model that comes out, and you want to make sure that you have eval set up so that you can trust when you're going to upgrade.
1000% agree with that last piece of advice. It's striking how many people don't have a good evaluation framework set up and still want to do all kinds of experimentation. I agree, it's totally counterproductive.
One of the things that I kind of toy with this idea that so many people are using LMs in their applications, and I would love it for Helm to be a sort of an aggregator of all the things that people really wish LMs would do for them, and somehow represent those use cases. Because then what happens is that people will naturally try to optimize for those. And if you're optimizing them at the task level, I think it's actually fine. If you care about particular, a topic classification task and you really want to do it well, and that's all you care about. Who cares if it can do a 5-digit arithmetic? You just have it represented in the Helm suite, and then let the model developers, optimize. And of course, if you're not optimizing for the actual, obviously you don't want to optimize for a test set, but if you're optimizing for it at the task level, then I think that's actually pretty productive. So if we could somehow as a community all get together and say here's what we want out of our LMs, then maybe it will be easier, I think, to make progress as a field in the direction that we care about, rather than having to guess. So I think what I'm saying is that I want that backward arrow as well, not just the users being just consumers of models, but also have a say in how they should be built.
Is there an easy way to contribute back benchmarks to you? I would be happy to do that myself. We should put a link in the
just submit a PR. It's really you don't have to write code. It's just here's a YAML file or a JSON file or whatever, and you can just run it. For benchmarks, which are basically let's say classification, or where you have a blob of text and you want to generate a few categories, so that's super trivial. I think if you want to do evaluation of generation, it's a little bit trickier. Just in general, we don't really, as a community, know how to do generation evaluation reliably. We have in Helm a bunch of evaluators set up, which include both mTurk and Scale, but also model-based evaluation GPT-4 and Claude, and then you can run all four and just have a sense of how these behave. We had a recent blog post that we put out last week, which was on comparing the 4 different evaluators for open-ended generation, and they're all kind of different. So it's it's a sort of unsolved problem.
Awesome. We should definitely put that in the show notes. It kind of reminds me actually of another thing that comes up all the time on this interview series lately, where I think people typically argue that there'll be a future where there's lots of different LLMs that serve lots of different use cases. And my worry with that is like the people that really argue for this, like for example, Jensen on an old Gradient Dissent episode, really believes in this future of tons of different LLMs. But I worry that those folks have kind of a vested interest in that world. And you can also imagine that really these tasks are just pieces of general reasoning, and being good at one task actually helps you on another task. So you end up with sort of one massively trained LLM like a GPT-4 that does really well across a wide variety of tasks. There's sort of no reason to use a specific model, especially if you can fine tune it. How does your benchmarks make you think about that? Like, are there models that are really good at very specific types of tasks that you would recommend, or are the best models generally the best across a wide spectrum of benchmarks?
Yeah, I think that's a really great question. Currently, HELM and many of these benchmarks look at just general performance, and then there's not really much of a there's some variation. Like some models are better at code, some models are better at multilingual, but on the whole, I think there is a sort of the principle, eigenvector is pretty strong. I think that the two views of one model versus multiple models isn't incompatible. I think it's a default world having a few strong base models plus a ton of fine tunes, I think is likely the world will inhabit. Because given the cost of training a model, I don't think there's going to be a ton of like training from scratch. But I think there's going to be more than like 3 models because of training from scratch, because there are different languages, different actors who want their own model, and they don't for whatever reason trust American companies or whatever, or just want to have control over that. And I think there's a lot of legitimate reasons why you want to have control over your training data, not just like take a bunch of weights off the internet and base your entire infrastructure on that. I mean, I think if you have the resources, then I think it makes sense. There's also cases where there's just a ton of private data. Like we're talking mostly about LLMs trained on public data, but the amount of private data dwarfs, I think, the amount of public data that you can train on. And of course, there's a lot of privacy issues around that, but if you could figure out how to leverage that data, I think you can train a lot of different interesting models that are very custom, but still would really dominate any sort of existing model. I think the way to maybe think about it is that these GPT-4 or any of these models are very generalist. They don't really understand. They understand like things can be reasoning and understand the world in general, but they don't understand like your organization at the level that someone who is really deep into it does. So if you could take, let's say, all the data in your organization, and you could probably train a pretty sophisticated foundation model, even if it's not at scale.
Well, switching gears a little bit to agents, where I know you've done quite a lot of research. How do you think about benchmarking agents? I mean, that seems like a much tougher problem.
Yeah, so there's 2 ways you can think about it. You can be benchmarking language models in the context of an agent, or you can be benchmarking agents systems. And for the latter, actually not that much has to change, because the way we did architected HELM, we're benchmarking basically an API that takes inputs and returns outputs. So behind the API is the model developer's business. They can go make use tools, do some crazy tree of thought and aggregation and self-consistency or whatever, as long as the the string is returned at the end. So you can think about HELM as evaluating agent systems already. Now the data sets that we have should probably be upgraded to be a bit more challenging for agent and involving more, let's say, recent events or more calculations or whatever. So I just want to say that, the benchmarking a language model and an agent system is, the type signature is basically the same. The second thing you can do is say, okay, we're interested in benchmarking how well a language model is with respect to it being deployed inside a larger system. And for that, I think there's just tons of different agent benchmarks these days. We have one called ML Agent Bench, which looks at how well a language model is at essentially solving ML engineering tasks. Like you give it a Kaggle competition, it's like, hey, make the accuracy go up by 10%. Here's a shell, and you can execute Python, go. And it will, the strongest agents will maintain a research log of I'm looking at the code, I'm looking at the data set, here's a plan of what I'm going to do. I'm going to try to change the architecture. Okay, it makes a code change, then it executes the code, it generates a log, and then it looks at the log and says, okay, maybe it's overfitting, so I should change this hyperparameter or whatever. All of this is, I would say, unreliable, but it's sort of exciting to see this sort of work, at least for some benchmarks, because it does suggest that in the future we might be able to see fairly capable systems that and that can actually improve ML systems. And we chose this for a reason, because I guess selfishly, as an ML researcher, if you can accelerate your own work, then you're off to the races. And it's like this idea that where people worry about, the benchmarks are too easy. Well, if you really can solve this, then I don't care if it's too easy. It's really helping people develop, making ML better.
Well, how often is it actually able to do that? I mean, I find every time I work with agent-based systems, it feels so evocative and powerful, but then realistically, I've not really been able to get them to work reliably enough to use them. Even, my co-founder, Sean, made this kind of awesome system where you could give it engineering problems, and then it goes off and does it. And he says he uses it, but the times that I've tried to use it, I've ended up spending a lot of money and it's sort of like looping a little bit. And, maybe I just was unlucky with the requirements, but how often can you actually get one of these to improve a Kaggle benchmark? I mean, that seems like a very good test, actually.
Yeah, it's so totally. These are definitely unreliable systems right now. But one, wait 6 months, we'll see.
Totally.
And second, if you're in a situation where you can actually verify the result, and also if you can put a human in the loop, or the stakes are low enough where if it errors out, it doesn't really matter, then I think this can still be useful, even if it's not solving these Kaggle competitions with 99% reliability. And I think there's a whole research to be done, like how can you develop these human in the loop systems where it can actually do a pretty good job of some subtask, and maybe a human that's guiding it along and suggesting ideas. It can, like a more of a research co-pilot, it could actually, be pretty useful.
Totally. I hope that agent decides to use weights and biases, and I'm wondering if we have any agent users in our system.
Yeah, we'll hook it up.
All right. Well, it should know to hook itself up if it's a good agent.
Yeah.
But I guess if I take a general purpose like agent framework and I apply it to a general purpose task, can I actually improve the HELM results? Like, are the best HELM systems like an LLM wrapped inside of an agent, or does the raw LLM work to a similar quality?
Well, so the models evaluated on HELM are more or less language models. So there's no agent stuff in them right now.
But you could imagine, like, like there's these stories, right, of like in reasoning, kind of adding a step where you actually like go back and like check your work could improve. Does that actually happen in practice?
You definitely can improve the results. And so some of like the Gemini results on MMLU are there's a lot of stuff that happens. And that's why the results are so high compared to when we do it in HELM, which is basically here's 5-shot learning, go. You output an answer, maybe with some chain of thought, and then and so there's a lot of mileage by just doing fancier prompting. I guess what to make of it. I guess you can take a view that, well, you really shouldn't have to go through all these gymnastics to like call a model 10 times in ensemble. Like that's the model developer's responsibility to make a better model. Like why would you push the burden of like having 10 times the number of tokens and cost on the user? That just doesn't seem right. So we sort of in HELM, we take the perspective of we prompt it with clear instructions where any human would be able to just do it. And it's up to the model to marshal its computational resources to solve the task.
That makes sense. Okay, at this point, what do you feel is holding back agents from broader adoption? Is it the quality of the model itself, or something about the way the systems are constructed, or something else?
I think that, well, first, the LMs are just not good enough for agents that have to do really long-range planning and more sophisticated action. Like the promise of agents is that you can set them loose and they can do something really complicated, but I think the LMs are just not there yet. And even if they were there, I think they're on benchmarks. There will be a sort of a trust issue where, if you have an agent that's taking 100 steps and actions autonomously on your behalf, like how do I know it's not actually doing the right thing? And part of that might be a sort of a user interface issue. Like how do you even show to the user and let them, inspect like what the agent is doing? On top of that, I think one thing that doesn't get talked about enough, I think, is the security issues with agents, because once you are able to execute code and do things on the internet, we know that language models have tons of vulnerabilities, right? They have the subject to prompt injection, and you can imagine that an agent that is your assistant that reads your email for you and performs some tasks, that's like a blatant, obvious way that for your account to get hacked. Like someone just sends you, I send you an email with some payload and it just takes over your agent. Like, and we don't even have a way of guarding against this right now. So I think we need to, spend a bit more time ironing out the security concerns before we really push on just kind of doing agents or hooking up agents to bank accounts or whatever.
Well, yeah, I mean, I think that's totally fair, but I guess unless you kind of count RAG as an agent-based framework, which maybe you should, but sort of setting that aside, I don't really see any real-world examples where agents are working well enough that I want to use them. And it sort of seems like that's kind of the bar first before the security issues are enormous. And I don't know how you solve them, but I'd be kind of curious to see an agent work really well in a low stakes situation first. Do you have examples where you feel like you've got an agent doing things where you're like, hey, this is useful enough that I want to use this for some business purpose or some practical thing in my day-to-day life?
Yeah. I agree with you that they're not ready for prime time yet. with the exception of like RAG. Obviously, that's great. I bring up the security issues that I think we want to get ahead of that. I do think if you look at the current trend of model improvement and scaling, that within a year, I think we'll be in a very different place, especially given that there is much more attention on agents. And when there's attention on something and people trying to optimize for it, that that the agents are just going to get a lot better. Because I think there's probably a lot of headroom in actually creating data that is agent specific. Like you it basically learns how to do the agent thing rather than just relying on like a raw language model to like magically figure it out.
Well, look, I mean, shifting gears slightly, I wanted to ask you about your TED Talk that I think you gave last year, where you kind of talk about the danger of closed source models. And I was actually kind of wondering if you still agree with all the things you said, because my experience of the last 6 to 12 months has been sort of an explosion of enthusiasm and actually progress in open source models, where I think it's actually changed my view slightly about the level of danger of closed source models taking over. So could we kind of get an update on Percy's perspective there?
Yeah, so I think largely speaking, I think my views are the same. And then when I was making the TED Talk, I was careful to choose things I would most likely believe in 6 months later.
Good job. That's tough to do in this space.
It is true that there's been a lot of movement in the open model ecosystem. There's a lot of interest, which is great. I would say that, so the TED Talk actually is broader than just having open models. And by open models, I mean models with widely available weights. Well, first, there's transparency, which I think is very helpful for policymakers as well as downstream developers and users to know what they're consuming. And I think the open model still falls short of that because there's no training data available for most of the the capable models. And going back to what we were discussing, like without the training data, it's hard to even know how to interpret your evaluation results as a starting point. And so I think the level of transparency could still be improved even for open models. The second point I made in the TED Talk was that how do we decentralize or take into account different values? Because when we talk about alignment to human values, whose values are we talking about? And even if you have open models, it's certainly the case that at least you still have a few organizations that are able to make the base model. Now it's a much better situation because now you can fine tune the model, so you can customize your model to however what you think are the values should be. So there's more plurality there, but some of the really subtle biases and whatever could still be baked into the original model, and that's something that's I think interesting to think about. And regarding that, the sort of the idea of centralization of power that comes with the closed models, I think that is partly diffused by having open models and letting people build on top, but it's not completely diffused because obviously there are only a few people who can train the models and the base models, and it would be nice if there were more participatory process for determining how these models are trained, whether they should be multilingual or not, things like that. And the third point I made was that, which is still not addressed, is that the issue of creators, where we're training these models on all this data that's created by artists, writers, programmers, and this data is taken usually without any sort of attribution, and this obviously is problematic. As you can see, there's a lot of lawsuits flying around about like, hey, you can't use my data. Well, but if we could set up a better attribution or economic system where there's actually credit that goes all the way back to the creators, then maybe we can mitigate some of these concerns. And also, how do you incentivize people to create better data than just rely on scrapes? So I think there's a lot of other outstanding questions that are beyond the sort of open to closed the distinction.
Is there a model where you feel like, hey, they're really doing it right? I mean, we've had people also in this interview, like one of the founders of Luther, I think, who talked about actually having an open community process to deciding, where to allocate the resources and what to train on. Like, do you have kind of a favorite model that you'd point to, or a family of models that is more open in this way that you're talking about?
Yeah, I mean, I think Luther and the Big Science Project, I think they did a remarkable job of involving the community and having much more open development. So I'm a big fan of their work. Of course, their models are not the ones that are used by the people downstream. People use Llama and Mistral, for example. So I think the key question is, how do you can have great principles and but you still need to figure out how to make it scalable and make it so that the actual, let's say, frontier models are actually developed in an open and transparent way. That I think is I don't know how to get there or whether it's possible or not.
Totally. Switching gears again, I guess you're also co-founder of TogetherAI, which has been making a lot of noise lately. Can you describe Together for someone who hasn't heard of it and tell me the story of how you founded it?
Yeah, so Together is a company co-founded in 2022. And again, the motivation back then was that we wanted to support open innovation, open models, and we needed to resources more seriously than what you could potentially do in academia. So the goal of Together is to build a platform for developers who want to do AI of any sort. That's kind of the broadest picture. And the current bet is that open models is the key to that's a world that we want to live in, where it's kind of like if you look at open source with Linux and Apache and all these other and sort of the web stack, it's all based on open standards and open source. And the vision is for AI development to look like that, because clearly it's been really beneficial and successful for software. So currently, we have an inference API where we a fine-tuning API where we allow people to take the state-of-the-art models such as like Mixtral and Llama, fine-tune them, serve them, and mainly we are trying to make it as easy, fast, and cheap for people. Concurrently, we are also developing models. Last year, we put out the Red Pajama data set, which was in the V1 was essentially a replication of the Llama 1 data set, but V2 is a much larger set of tokens from Common Crawl with different quality signals. So the goal of that work is trying to enable the community to develop these models in a more open and transparent way. And we're getting more GPUs, and hopefully soon we'll be training more models as well.
I guess it seems like there's been an explosion of offerings for fine-tuning and inference of open source models. Clearly, you're actually pretty early to that space, but how do you think about yourselves as opposed to competition?
I think we're pretty good.
And good here means like sort of cheaper and faster, or what does good actually mean?
I think we have I think it changes, but I think we have the cheapest and fastest by some metric. And I think but that's, I feel like that changes, like, and I think the main difference is that we have sort of expertise in the full stack. Like, we have people who train and build, not just through inference, but we do model building and data work. And long term, I think the goal is to offer not just like an inference API, but more of a whole set of suite of products around the whole developer ecosystem, including benchmarking, for example, so that you could come. I think right now, users want more than just like, I want to do inference and Mistral, right? There's so much more to developing an application, and I think at some point, having the expertise in trying to help with the training and the evaluation and the data work needed to build models, that's where I think we'll shine. Another, I think, a unique thing is that we are coming from Stanford is we are very connected to the research, and a lot of the advancements. This is from like Chris Ray's group on like flash attention, TreeDAO on flash attention, flash decoding, hyena architectures. They're really, I think, cutting edge technologies that we are building into our products. And these things, and we do that because they actually move the needle, substantially. So I think that's our, I think, edge.
All right. Well, I want to end with a totally different question. I hope this is interesting for you, but I saw that you're a pretty successful pianist and have won several competitions, and I've been kind of struck by how many musicians we've had on this podcast, and also how many musicians I have inside of my company. I was kind of curious if you feel like there's kind of any music AI connection, or if music has sort of affected your career in any particular way.
Yeah, totally. So, I've been a classic pianist since I was 8, and I still play actively, although maybe less actively than when I was a little bit younger. But it's something it's always been a part of me. And for a long time, I was thinking, how can I combine the AI work and the music work? I remember in grad school thinking like, it would be really great if I could build models of music, so I could generate music or generate performances of existing music and so on. And the time was just not right back then. This was like 2010 or something. I tried again with one of my students, Robin, who was also a pianist, in 2017, and we did some work then, but it still wasn't quite there. But in the last 2 years, I had 2 amazing postdocs, Chris Donahue and John Thixton, pass through my lab, who have actually, their priority is doing music and AI work. So I had the great fortune of working with them, and with John in particular, we are training foundation models on music, and this is extremely exciting to me because first, you don't actually need huge models to actually have compelling music generation, and we especially since we're working with symbolic music like for MIDI, it's very scalable. So even with like a GPT-2 size model, you can actually generate some pretty compelling music. And it's actually, and what we focused on is actually training models which are much more controllable. So like, if you want these models to be useful for actual musicians, it's not that interesting to just like push a button and say, okay, boom, generate a music. They want to be able to edit and change the music and having basically control generation. And that's what we're building with something called an anticipatory music transformer. It's basically a generalized infilling model that allows you to take in a melody and add accompaniment or rip out a section and generate variations. So we're having a lot of fun with it. And also we are actually working with some producers down in LA to try to see if this can be really game changing in that industry.
That's cool. Do you have any samples of the music?
Yeah, it's online. I can send it to you.
Oh yeah, we should add some to this podcast so
sure.
people can hear it. Send me your favorites. I guess it's funny that I feel like classical music in general and piano is I feel like it's pretty far out in the sort of like kind of like virtuoso emphasis. It is like I feel like it's such a skills based thing. Like the idea there's even a music competition, might not happen in like other genres. Like, and also I feel like this sort of AI and computers probably can like play music sort of more like perfectly than a human. Does it like kind of change your relationship with music at all to sort of watch automation get better and better at making it?
So I think the short answer is no, because I feel like the value of music, putting aside all the AI research, is really personal for me. Like being able to play and feeling that you can play something, and it's sort of a subjective experience that is just not really, replaceable. It's just like, people still enjoy doing like track and field, even though like, of course you can hop on a race car and go around much faster. So I don't think that changes. I am as more of a, one thing I remember is back in 2010, I was really intensely trying to compete in these piano competitions, and I would just not be able to find enough time in the day. I had like musical ideas, like, okay, I really wanted to sound like this, but I didn't have the time to like sit down for 8 hours and practice. And whereas, obviously the people who are, spend their whole careers doing this, that's what they do. And so I always thought it would be really cool if I could somehow translate the music ideas that I have into actual music somehow, like a basic augmentation of some sort. So to make up for the fact that I didn't have 8 hours a day to practice. One day maybe I'll get there. But right now I have too many other things to do. Maybe for a project for retirement.
Awesome. Well, thank you so much for your time. I really appreciate it.
Yeah, thank you for having me.
Fun interview.
Yeah, that was great.
Thanks so much for listening to this episode of Gradient Dissent. Please stay tuned for future episodes.